Okay class, just now we see on the first case of Cauchy-Euler equation when it's involved the homogeneous Cauchy-Euler equation where you have your right hand side equal to 0. Now we move to the second case which we are dealing with the non-homogeneous Euler equation. So when we have a non-homogeneous Euler equation, it means that your right hand side is not equal to 0. So, when you have non-homogeneous differential equation, what you need to do is you need to find what is YC and what is YP. So, YC will be found by using the previous method that we learned before, which is by letting y equal to x to the power of m. Okay, and then we have our y prime equal to mx to the power of m minus 1, and we have our y double prime equal to m multiplied by m minus 1 x power of m minus 2. We will get our yc, and then to find the yp, we will use the variation of parameter method as we learned before in the normal differential equation. Okay, so kita akan guna variation of parameter method untuk kita cari YP. Cuma untuk kita cari YC, kita guna method of Euler equation. And then we will use the superposition principle to combine our YC and YP to get the general solution of our differential equation. So for non-homogeneous differential equation, you need to remember that it will involve two solutions, which is the complementary solution and also the particular solution. So first of all, we need to find our YC. So to find our YC, we let our y equal to x to the power of m as before, and then we have our y prime equal to mx to the power of m minus 1, and we also have our y double prime to be m multiplied by m minus 1 x to the power of m minus 2. Then what we need to do is we need to substitute it. Okay, substitute the value here inside your equation. So what you have here is x, your y double prime is this one, m square minus m x to the power of m minus 2, minus with your 4y prime. So this one is your y prime. We let it equal to 0 because we want to solve the homogeneous part to find the YC. Okay, so what we have here is m square minus m x to the power of 1 darab dengan x to the power of m minus 2, minus with 4m x to the power of m minus 1 equal to 0. So you have here 1 minus 2 is minus 1. So what you have here is m square minus 1 x m minus 1 minus with 4m x m minus 1 equal to 0. So what you can see here is you have x minus x to the power of m minus 1 here, and also you have x to the power of m minus 1 here, means you can factor it out. So what you will have here is x to the power of m minus 1 in the bracket is m square minus m minus 4m equal to 0. So this one we bring to the right, we will get equal to 0. What you have here is m square minus m minus 4m is minus 5m equal to 0. So you factorize m, you have m minus 5 equal to 0. So your m1 equal to 0 and your m2 equal to 5. So now you have two different value of m, means you have the real and distance root. So for real and distance root, your yc will be x to the power of c1x to the power of 0 plus c2x to the power of 5. Okay, and x to the power of 0 is equal to 1, therefore your yc will be c1 plus c2x to the power of 5. So this one is your yc. Okay, so now we want to find what is our yp. So when we want to find our yp, now we want to use the variation of parameter method. So if you already forget, you need to go back and check your notes. Okay, to start variation of parameter method, we need to know what is our y1 and what is our y2, where y1 and y2 come from your yc. This one is your y2 and the one here is your y1, which is 1. X to the power of 0 is 1. So your y1 is equal to 1 and your y2 is equal to x to the power of 5. From here, you will get your y1 prime equal to 0, your y2 prime equal to 5x to the power of 4. This one is the first step of variation of parameter method. And then we need to form the equation, where the first equation will be y1 u prime plus y2 v prime is equal to 0. Okay, so your y1 is 1. 1 multiplied by u prime plus your y2 will be x to the power of 5. V prime is equal to 0. This one is your first equation. Your second equation, your y1 prime u prime plus your y2 prime v prime is equal to fx over a. Okay, so you have your y1 prime equal to 0, means 0 multiplied by u prime is 0, plus with 5x to the power of 4 v prime equal to fx. Your fx is the one on the right side, so x to the power of 4 divided by a. A is the one at the front of second derivative, which is x. So you will have your second equation as 5x to the power of 4 v prime equal to x cubed. This one is your second equation. Okay, so step number 3, this one is step number 1, this one is step number 2 in the variation of parameter method. Step number 3, you need to transform your first and second equation to be in the form of matrix. Okay, where we have the variable u prime and v prime equal to 0 and x cubed. Okay, so you just need to put the coefficient. This one is 1, this one is x5, this one is 0, this one is 5x to the power of 4. Okay, and then your step number 4 in the variation of parameter method is to find the value of Wronskian, where to find the value of Wronskian, we need to find the determinant of this matrix. 1, 0, x5, 5x to the power of 4. Okay, so how to find the determinant value? You multiply this one. Okay, 5x to the power of 4 minus with, you multiply this one, 0. So you have your Wronskian value equal to 5x to the power of 4. Next, in step number 5, we need to find our u prime, where our u prime can be found by finding the determinant of u prime. What is the determinant of u prime? You need to change, or you need to substitute the column first with this one. With this one. So you will have 0x cubed here, and this one you just copy back, x5 over x5, 5x to the power of 4 divided by your w. Okay, so determinant of this one is multiply 0 and 5x power of 4 minus x power of 3 multiplied by x power of 5 divided by w. Your w is 5x to the power of 4. Okay, so this one is 0. So you have negative x to the power of 8 divided by 5x to the power of 4. So you will have negative 1 over 5x to the power of 4. This one is your u prime. Okay, so you need to find your v prime. So your v prime is the determinant of matrix V. So how to find the matrix V? To find matrix V, you need to substitute this column with this one. Okay, so we have 0, x to the power of 3 here, and the first column just need to copy back, and it must be divided by the Wronskian value. So you have this one multiplied by this one, so you have 1 multiplied by x cubed minus with 0 multiplied by 0 divided by your Wronskian value is 5x to the power of 4. So what you have here is x cubed divided by 5x to the power of 4. Okay, so you have 1 over 5x as your v prime. Okay, so now you already have your u prime, you already have your v prime. You need to find what is u and v. So in step 6, we want to find what is u. So to find what is u, we need to integrate u prime dx. Okay, so your u prime is integration of negative 1 over 5x to the power of 5 dx. So what you will have is negative 1 over 5 x to the power of 5 divided by 5 plus c. So you will have negative 1 over 25 x to the power of 5 plus c. This one is your u. Okay, and then we want to find our v. Our v is integrate v prime kepada x. So your v prime is 1 over 5x dx. So you will have 1 over 5 ln x plus d. Why d? Because here we already use c. So now you already have your u, you already have your v. You can find your yp, where yp by variation of parameter is u multiplied by y1 plus v multiplied by y2. And you already have your u here, negative 1 over 25x5 plus c, and your y1 is equal to, where is your y1? 1 y2 x5 plus v y2. So here is your v, 1 over 5 ln x plus d. Your y2 is x to the power of 5. Okay, so here is your yp. You can open the bracket. You will have your yp equal to negative 1 over 25x to the power of 5 plus c plus with 1 over 5x to the power of 5 ln x plus dx to the power of 5. So this one is your yp. So now you already have your yp. You can find your y by combining your yc and your yp. Just now we have our yc equal to c1 plus c2 x5. Okay, so y equal to c1 plus c2 x to the power of 5 plus with your yp is all this one. Okay, so we just need to copy and bring everything here. Okay, so now you can combine which one is the same. So if you can see here, you have c1 and c, both are constant. So let's put it together. We have our y, c1 plus c plus with, and you can see here the c2x to the power of 5 with dx to the power of 5. We can combine them. So we will have c2 plus d x to the power of 5. We have another one, which is this one. Okay, so we have c2 plus d minus 1 over 25 x to the power of 5, and this one is the rest, plus 1 over 5 x to the power of 5 ln x. Okay, if you can see here, constant plus with constant is another constant. So let's write it as a plus constant plus constant plus constant is another constant. Let's write it as b x to the power of 5 plus with 1 over 5x to the power of 5 ln x. So this one is the solution to your Euler differential equation when it's involved the non-homogeneous equation.